Okay, so let's take a look at our second problem for today, and this one is about a person named Emerson, and they will actually pay for a t-shirt that I have to buy. It cost me $3, so they're going to pay for that. He's agreed to pay for the shirt, and he'll also pay me $2 for every mile that I walk. Now hopefully you've already taken care of your graph here. You've numbered it properly, you've labeled your y-axis and your x-axis. And so now we can launch straight into what we need to do every single time, and that is take this story problem and summarize it into a sentence. So it should represent this information. Maybe it's a little bit different than mine, but it should mean the same thing. Emerson will pay me $3 for the shirt and $2 for every mile. And that's talking about the miles that I would walk, right? So from here, I would like to take a look at filling out the table using this information. So we're walking a certain number of miles, and that's what we have to do in order to get paid. So the walking is our independent variable. That would be our x. So let's just make our x row the number of miles, and our y row would be the dependent variable. That's what we're getting from all of our work on the x row. It's the amount of money that we're going to be raised for this walkathon. So basically, if I show up, I get a free t-shirt, right? And if I show up, that means I've not walked anything in the walkathon, but I'm still getting the value of the shirt, and that shirt was worth $3. So this should be $3. But then if we go ahead and we walk 1 mile, then what takes place is that Emerson is going to give me another $2 on top of the 3s given for the shirt. And that's going to raise my total to $5. And then you can see how that pattern is going to continue every single time. I increase my miles, and then I add on another $2 to my total for the money earned. Another $2 gets me up to 11. Increase my mile by 1, increase my dollars by 2. And that's what we have. Now, the next thing that's really good here is to just pause and get our start and step numbers. Okay? Well, if you look at a table data, if you find an x that's 0, just steal its y. That is always going to be your start number. So this 3 is our start number, and that's why I'm making a note there. It's positive 3. Now, if you're looking at this situation right here, where are you starting with? Before you even walk 1 mile, he's going to pay you $3 for the shirt, so that's your starting number. Now, your step number. We talked about this one just a little bit before. Delta y over delta x, your change of y and your change of x. Look at your y change here. We were adding 2 every single time, right? So I'm going to put 2 up on top. And then what happened with your x's? It was a plus 1 every single time. So I'm going to put a 1 right there, and that does simplify to just a 2. A 2 divided by 1 is a 2. And that is a little bit more complicated, but again, when we get to the toning problems tomorrow, we're going to see a more complicated step number, and if we already have this basic idea right here, we won't have to learn anything new. So it's best to just jump straight in. Now let's go and start graphing this table data, but let's use the start and step number to create this equation, and then we can use the equation to graph it, and it's going to match this table data right over here. Our equation always starts with y equals. We always then put our step number next, and we slap an x next to it. And then our start number, since that's a positive 3, we'll put plus 3. If it was a negative 3, I would write minus 3. Okay? And before we start graphing it, let's just go ahead and label what our x's and y's are. Our x's are number of miles. So this x-axis right here is the number of miles. I don't like writing it in this box here, but it's just so close, that's what we have to do. And then our y number is going to be our money. So let's put that right over here. So these are our miles, and this will be the money that we make. All right, here we go. Our start number is 3. You can see it's right there. You can also see it's right here. So that just means please put a dot on the y-axis, not the x-axis, the y-axis. Okay. Now our step number is 2, and you can see it's 2 over 1. So we're going to step up 2 because it's positive. If it was a negative 2, we would go down 2, but instead it's positive, so we're going to go up 2, and then we're going to step over 1 because we had a 1 on the bottom of it. So up 2, and to the right 1. Up 2, to the right 1. And we just continue this pattern until we've run out of space. Once you get your dots plotted, go ahead and bring in the straight line. Now, if this bothers you a little bit, use the step number to actually come in and shade in the steps up to right 1, up to right 1, until you kind of get the hang of it. So we're hoping you don't have to do this too much, but that's the reason we call it a step number, because it builds the steps. They can be going up, or if it was a negative on top, we could be going down. Well, let's take a look at one last thing here real quick. How about if we took a look at what these mean in context to this story problem right here? What would the x mean? Well, your x's are the number of miles. So how about we just label that as, hey, number of miles. And on your y-axis here, it's money, or you can see over here on your table that y is your money. So this would be the money, or the total money raised. And then we've got this number right here. Your 2 was your step number. So that's important to just know, hey, that step number is always going to be multiplying your x for these linear functions, these situations that we're working on. And then this right here, the sign and this number that's being added or subtracted, that is going to be your start number. And that's what lets you be able to put it right here to start on your y-axis. And remember, now that we have this equation, you can plug in any value that you want for the miles, times it by 2 and add 3, and the number that you will get will be equal to the amount of money raised. And it matches up perfectly to this table. If we walked 4 miles, well, 2 times 4, see, that's number of miles, 2 times 4 miles is 8, and 8 plus 3 is 11. So let's just go see if 4 miles gets us $11. It does. And it's sitting right there on this table. But again, the true power of this is that now you can plug in any number of miles that you want and very quickly determine how much money that you would be raising. The visual graph is good to have, and we're almost done with it. The one thing we need to do is we need to go back through and we need to make a title on there. So how about we just call it Emerson's Walkathon. So we've labeled our graph, we've taken our equation and graphed it. Could you have just taken these ordered pairs and plotted them individually? Absolutely. But I do think it's good to start using the start and step numbers because it's a little bit faster actually. And it's a little bit more predictive too, a little bit more usable. And hopefully filling out the XY table is starting to become a little bit more natural. And the summary sentence is also starting to become natural. So keep working, keep practicing. We've got 2 more of these coming up tomorrow with a few more twists, and we'll keep building.